In this video, we'll look at dynamic equilibrium and Le Chatelier's principle. This is paper 2 content for IGCSE Chemistry. By the end, you'll be able to do 3 things. First, describe dynamic equilibrium. Second, state Le Chatelier's principle. And third, predict the effect of changing conditions. When a reversible reaction in a closed system reaches equilibrium, something subtle is going on. At equilibrium, the forward and backward reactions are happening at exactly the same rate. Because they cancel out, the amounts of reactants and products stay constant. They don't change. But it's not that the reaction has stopped. It's called dynamic equilibrium, because both reactions are still going all the time, just balancing each other perfectly. So what happens if we disturb an equilibrium? Le Chatelier's principle gives the answer: if you change the conditions, the equilibrium shifts to oppose that change, partly cancelling it out. So if you add more of a substance, the equilibrium shifts to use some of it up. If you raise the temperature, it shifts in the endothermic direction, which absorbs the extra heat. And if you raise the pressure, it shifts towards whichever side has fewer gas molecules, reducing the pressure again. Let's apply this to the Haber process, which makes ammonia from nitrogen and hydrogen. The forward reaction is exothermic. 4 molecules of gas become 2, so high pressure pushes the equilibrium towards ammonia, which is why a high pressure is used. A lower temperature would also favour ammonia, since the forward reaction is exothermic, but it would make the reaction far too slow. So a compromised temperature of around 450 degrees is chosen. Finally, an ion catalyst is added. It speeds the reaction up so equilibrium is reached quickly without changing the position of the equilibrium itself. Let's check what you've learned. Question 1. At dynamic equilibrium, how do the forward and backward rates compare? Question 2. State Le Chatelier's principle. Question 3. In the Haber process, why is a high pressure used? Pause the video and have a go. 3, 2, 1. Here are the answers. 1. They are equal. 2. If conditions are changed, the equilibrium shifts to oppose the change. 3. The forward reaction has fewer gas molecules, so high pressure shifts the equilibrium towards ammonia. Thanks for watching. If this video helped, please give it a like and subscribe to the channel for more IGCSE science revision. My revision workbook is available from the link in the comments.